Space weather, here's the sun at 3:04. The magnetosphere lost its angle and no one seems to notice. Hey! Yeah, we're not kidding. Did somebody turn the dial on this instrument or what? Here's the sun's extremely anomalous magnetic lines. And the SDO servers are a little slow. Let's look at the sun on 193 angstroms here. You can see a fairly well-defined coronal hole rotating in. Almost perfectly Earth-facing right now. No sunspots. And let's go check the data. So here we are at spaceweathernews.com, looking at an almost entirely flatlined X-ray flux. A couple little blips on the phi angle there. Excuse me, but no ongoing connection. And solar wind density is now up a bit. Often the predecessor to an incoming coronal hole wind stream. Solar wind speed is down, so we wouldn't be surprised if that upticked. Magnetometer's got some jagged sawtooth-like spikes in it there, and it looks like we're experiencing a higher low. So let's look for that coronal hole magnetic connection to come anytime, at which point earthquake risk goes up again. Okay, there's your KP index, which is at 1. So that's the standard low-level cosmic ray human health alert. GOES electron flux has been pretty flat, especially at the high density portion. Something else to keep an eye on. And speaking of ions, there is a little bit of perturbation going on in the proton flux. Something we haven't seen for quite a while. Not a lot of charging hazards, and the F2 layer is looking fairly discharged. We'll just leave it at that. Now, with that stuff in mind, here's your magnetosphere. Why is the pressure so low? Did somebody turn the dial on this instrument? I mean, let's give you an idea of what this looked like yesterday. And here's our video from yesterday. You can see how much higher the pressure is yesterday compared to today. The angle of attack on the bow shock and the magnetotail. Again, yesterday, today, extremely low pressure. This is the kind of situation that would cause plasma to just leak right into the atmosphere. So, I don't know if somebody manipulated the dial here on this or what's going on. It doesn't look normal at all. Although NOAA was informed of this yesterday and this morning. I actually commented directly on their Space Weather Prediction Center on NOAA's Space Weather Facebook page. Let's look at the density also, since this is so anomalous now. And here's your magnetosphere density. You can see plasma rolling in from the left in waves. And it sure looks like you have a bridge. An incoming bridge right there and right there. And those spots are not really located at the poles, especially the southern one. So, yeah. And let's also look at the velocity. And let me just say, perhaps this is the best data because this is measuring just a speed. And that's going to be the easiest factor to measure here. Let that play through twice. You can see this is still a very odd angle of attack. Something like this, when it's normally something like this. So we're waiting for the Earth to move through the heliospheric current sheet and keeping an eye on the charge. Let's just give you an idea of what we mean. Keep in mind this is all a prediction here. However, this does illustrate well what we're talking about. Here you've got the heliospheric current sheet. Here's the Earth. And the dotted line is the interplanetary magnetic field. It looks like the forecast does actually have the heliospheric current sheet returning to a closer spot to the IMF. That's something to keep an eye on, and the theory remains that the angle of attack on the magnetosphere is associated with this heliospheric current sheet. Please feel free to comment if you agree, disagree, have an alternative theory, etc. Now we're going to look at ground-based magnetic perturbation models. Thanks to the University of Michigan again for that, as they provide those magnetosphere movies as well. And since I have 20 tabs open here, I have done no prepping on this. I'm seeing this for the first time also. Yeah, maybe those models are right. I don't see any perturbations. So maybe nobody turned the dials on those magnetosphere things. But in the last couple hours, it looks like we have an uptick around the North Pole portion. Let that play through again. A little bit of magnetism spilling into the north. Next, we'll look at theplanetstoday.com. There's your planetary locations. As we stated yesterday, Earth is approaching a Saturn opposition. By the way, this is a great website. It's got all kinds of different views, and you can indeed advance. Okay, maybe I can advance. Anyway, if you press these arrows, you can advance so that you'll see where the planets will be on a different day. Cheers. Next, let's just look at the solar wind in real time here. So the BTBZ has just diverged quite a bit from zero line, which is another indication of earthquake risk. When the BZ, which is this red line, gets very low, tends to be associated with earthquake risk. Also, we see a little sputtering of the phi angle here, indicating a sputtering connection with coronal holes. 4.17 protons per cubic centimeter is the density. 410 kilometers per second is the solar wind speed. Let's look at some cosmic ray monitors. Here's the Moscow neutron monitor. Fairly high levels of cosmic ray flux picked up in Moscow. Actually, the highest that we've had since the very first part of December. So that's something to keep an eye on, especially with the magnetosphere as weak as it is. Here's the Athens neutron monitor station. Not as big of a variation at this cosmic ray station, but there's your data for that one. And here's Mexico City. You can see at the end of the last few days there, the range has been tightening, and it's pretty much, they're pretty much all agreeing. We like these cosmic ray stations as they tend to have correlated data. And we like to see that. I noticed some of the Antarctican ones are showing something totally different. Next, let's look at an article from 2013. How scientists stop light dead for a whole minute. So, speed of light's absolute, is it? How do we stop it in a laboratory? Well, we took some lasers, fired the lasers through a type of crystal, and then we fired another laser through the crystal, and then turned off the one laser, which had some effect on the structure of the crystal, and the other laser stayed inside. We were also able to retrieve information after basically putting it on pause. Why are we talking about this? Well, because this affects our fundamental understanding of the universe. Because we use light in order to measure things like the distance of stars. We think we're measuring the mass of stars. And think about the implications on redshift and blueshift on a cosmological scale if light can be stopped dead in its tracks in a laboratory. We'll leave links to that article also. And as a value-added service, here's your U.S. Doppler radar view. I know some of our viewers watch our video first thing in the morning, part of the reason why we post them so early. There you go. We got some snow spreading across PA, New York, Ohio, West Virginia, Minnesota, Wyoming, Montana, etc. The rain that inundated the East Coast yesterday is finally moving off to the Northeast. Thanks to AccuWeather.com. Let's look at the AccuWeather water vapor map for once. Here you can see this U-shaped portion of the jet stream is now finally moving off to the east. And the reason we look at the water vapor map is because the Doppler may not always show you what's happening, as the turbulence in the atmosphere really occurs when these moist, less massive areas come in contact with these dry, more massive areas. So, quick little tidbit. When you look at these kind of maps, these dry areas are almost always associated with high pressure. And these wet areas are almost always associated with low pressure. Also remember, dry air tends to be colder and is more massive than wet air due to nitrogen being more heavy than water in the atmosphere. Let's look at the earthquake situation. Idaho. Idaho got an earthquake, 2.5. Indonesia, 5.1. Papua New Guinea, a 4.9 at depth. They should stay on alert for a 5. Looks like a major swarm in the South Pacific. Another 5 in Russia, 5.4 in Russia, a 5.6 in Russia. Hopefully that's the peak of that upturn. .9 in Colombia. Another 4.9 in Russia. 5.1 in the South Sandwich Islands, another very far south. Those of you who are not aware, earthquakes tend to happen closer to the equator, not closer to the poles. Vanuatu gets a 5.0. It's a bit of an uptick in earthquakes here. There we go. There's a deep one at Papua New Guinea. Papua New Guinea needs to stay on alert for a 5.5. Fiji gets one at 550 kilometers. Fiji stays on alert for a 5. That's quite a swarm at Russia. We're going to zoom in on it in a minute. 5.3 in Zimbabwe. Looks like that one must have caused some damage. Right in the African Rift Zone. Indonesia, 4.6, 4.7 Papua New Guinea, 4.6 in Pakistan, and the Chagos Archipelago region. I never heard of that one. Let's zoom in on that Russian area. Get a visual on how many quakes happened there. On both sides of the plate boundary. Moving on. Now let's go to a phys.org article. Thank you, Princeton Plasma Physics Laboratory. It's Xuanfei Dong. What did Xuanfei Dong do? Something very crucial. The Parker Solar Probe is probably going to corroborate his findings. What he was doing was looking at why it is that the corona speeds up and gets hotter. And looks like he reproduced in a laboratory the situation that's actually going on. And all you Electric Universe people out there will appreciate it, because you're correct. I'll just read this paragraph. The new findings suggest that the formation of plasmoids in elongated current sheets within the plasma helps change large turbulent eddies into smaller whirlpool-like structures. This process creates localized, intense electric current sheets in the plasma that affect the rate at which magnetic energy dissipates in the sun as it flows toward the corona. In other words, magnetic fields are in charge. Cheers. Thank you very much, Princeton Plasma Physics Laboratory. Nice work, Mr. Dong. By the way, I've always wanted to say that. Thanks again, Mr. Dong. Lastly, let's look at an article from Universe Today demonstrating fundamental misunderstanding of how cosmology works by astronomers. And I quote, "Eventually pieces of the gas cloud shrink and shrink, compressing themselves into tight little knots. If the densities inside these knots get high enough, they trigger nuclear fusion, and voila, stars are born. Except stars form through condensation reactions, not through gravitational accretion." Anyway, we'll leave links to that article also. And here's a cool picture. Ooh, it's a composite of 2 different telescopes. And as the magnetosphere is doing the limbo to challenge our very notions of how low it can get, as that occurs, don't drink. And if you drink, don't drive. And if you're going to drive, don't drive. The U.S. Department of Transportation estimated that over 100 million people were out driving yesterday. I was one of them, except I wasn't doing it for holiday travel. I was doing it for science. So, if you're driving, don't drink. If you drink, don't drive. And if you drive, don't drive. Take a plane, take a bus, take a unicycle. Thanks for watching, everybody. Please share on your social media. Share on NOAA's Space Weather Prediction page. And share in all of our Facebook groups, as Facebook still has us banned. Congratulations on your stock price, Mark. Seriously, though, thanks, everybody. And thanks, colleagues. Anomalous Howard, the Starman, and that other fellow from North Carolina. Cheers, guys. Nice work.